If you're watching these videos in sequence, the first one is how to calculate or estimate costs in a production system that uses a level production plan. Remember, a level means every month, same amount. What's the purpose? The purpose is to minimize the fluctuations of labor. We don't want them being hired and fired because there's a cost associated with it. Or is the production process itself is simply cheaper to let it continue to run than it is to shut it down, open it, shut it down, open it. Well, now we want to look at a chase method. And what we're trying to do here is very, very different. Here we are manipulating labor. We're hiring it, we're releasing it in an attempt to meet the demand for the product each and every month. Okay? So the steps here are slightly different than they were in the level method. Here's what I need to know. The first thing I need to know is how many workers will I need in order to produce 9,000 skis in the month of January. So my costs are now associated with hiring, firing, and production. And so I don't have holding costs anymore because I'm not holding any average inventory. I'm just trying to produce and sell at the same rate. So I need to know how many laborers it would take to produce 9,000 skis in the month of January. Well, if we go back here, here's what I know. I know that in a given time period, each employee can produce 40 pairs of skis. So here's the two numbers I'm looking at. Whoops, let me do that. So I've got 160 hours that a person can work in any given month. It takes them 4 hours to produce a pair of skis. So 160 divided by 4 gives me 40 pairs of skis that each worker can create during any given time period. So I'm going to use that over and over again. Also notice I use this ceiling function. You might want to use round up. It does the exact same thing. But the mathematical function ceiling takes a fraction and rounds it up to the nearest integer. Similarly, the mathematical function floor takes a number and any number and rounds it down to the nearest integer. I can't hire fractional workers. That is actually the point. So I use this ceiling function so that I can get integers. And if it takes a half a person, I got to have the whole person, so I need to round it up. Okay. So I've got 9,000 skis that need to be produced in the month of January. That's the D3. And then I'm going back to the last tab, the level tab, and I have 160 pairs of skis, 160 hours per worker divided by 4 hours per pair of skis, so that this denominator is saying, okay, well, that's 40 pairs of skis that each person can create. Well, I need 9,000 of them. As a consequence, I need to have 225 workers in order to construct a pair of skis. Now, also notice, nowhere in this list on the demand side do we ever bump this capacity constraint. And so this capacity constraint is not going to bind, that's the word, we're not going to hit it. So we're okay in the production process. We can hire labor that will produce this 9,000 skis. We have the room. Okay? All right, well, if I need 225 workers and I started with 100 workers, that means that I have a shortfall of workers of 125 people. Okay, well, how am I going to get this? And I admit this looks like a mess, right? But let me kind of walk you through the Excel's if function. What it does is between this parenthesis and the first comma, it gives a condition. So what it's saying is if E3 is bigger than, what is this thing? Well, it's from the prior page, and it's that 100, that current level of employees. So here's what it's checking. Is this number bigger than 100? If it is, I have to have more labor. Okay, how much more labor? Again, I can't hire fractional labor. So what do I need? I need my 225 minus the current level of employment. So this would be 225 minus the 100 that I already had employed, and that's going to calculate the number of people I need to hire. Well, what happens if this statement is not true? What if the current level of workers was less than 100? Well, then I don't need to hire any more workers. So I'm going to hire 0. So in this second argument is how many people I need to hire if the statement's true. If the statement is false, I don't need anybody. I just hire 0. Okay. Similarly, what about firing? Now you see the condition flipped. Okay, now I've got the condition, is the number of workers I need less than or equal to the number of workers I have? If it is, then I need to know how many workers to fire. And that's going to be the number of workers I have minus the number of workers I need. So again, if this statement is true, it's going to evaluate this second argument. But if it's not true, which in this case it isn't, I'm going to fire nobody. So 0. All right, now I know I referenced the prior page above, but I don't have to here. Now all of a sudden I just have to look into the previous month. In January I had 225 workers. In February I need 175. So just asking, is 175 bigger than 225? The answer is no. So I'm going to need to hire no one. That's what my if statement says. This is not true, so 0. Okay. Now check the fired. Well, what if 175 is a smaller number than 225? Well, if that's the case, then the difference between these two numbers is E3 minus E4 is the number of people I need to lay off. So this is a true statement. 175 is in fact smaller than 225. So I need to lay off the difference between these two, which is 50 workers. And then I can just do these calculations all the way down. So that I know how many people I'm hiring, how many people I'm laying off. Now I have a cost associated with my workers, the hiring of workers, and the firing of workers. So in step 3, I'm going to calculate these costs. Okay? So let's go back. What's in levels D3? I think you'll find that in levels D3 is the time it costs to make a pair of skis at regular time. We're not paying any overtime in this chase method. We're hiring and firing workers instead. Okay, so in this method, I have to pay $300 per pair of skis. So my production costs are going to be 9,000 times the 300. So this is a 300, this is the 9,000. And that just stays the same, meaning the calculation is the same all the way down. So for production, the total cost, $14,400,000. That's what the production costs are going to be for me to use this chase method. But to hire and fire people, that's different. Okay? According to my prior over here, it cost me $500 to hire a person. It cost me $300 to lay a person off. So in this particular cell, there's the $500 times the number of people I have to hire, plus the $300 times the number of people I have to lay off. So in the first month, I pay $62,500 to hire 125 workers. And I can just continue this total cost for hiring and firing all the way down to the bottom. So over the course of the year, I'm going to spend $197,500 hiring and firing people, which implies that my total costs are the sum of all my monthly costs. Now I could just have easily have summed across this total, but I get the same thing. So, but what I did instead is in step four, I created the monthly cost by adding together my production costs and my hiring and firing costs. Now, I know this seems odd to be hiring and firing so many more people than in the level process, but notice my bottom line is less. So now you've got to decide, okay, will my production process meet this chase strategy? One of the things you need is a very available labor force. I mean, hiring 125 people in 1 month, that's a lot of people to hire. To lay off 50 per month and then fewer as we go, that's a lot of people to lay off. I could only do that as an owner if my conscience allowed me to do that. So your author gives an example of the chocolate that's being produced in Hershey, Pennsylvania, and apparently the available labor during the off-agricultural seasons, so these months, is pretty readily available. And it's probably people who have come to the factory year after year looking for employment. And so, they have a readily available labor force that's willing to work these kind of hours. So Hershey, Pennsylvania, the example was a lot of these people we're hiring already have summer jobs. We're just hiring them in the off season when chocolate sales rise during the winter. So that's the chase method. I'm hoping that I've explained it well enough.